Adjacent carbon is called as a beta carbon. Okay, so first we are removing the OH group from the alpha carbon atom. Then second atom we are going to remove from the beta carbon atom, in that we can call as a beta elimination reaction. So dehydration reaction is example of beta elimination reaction. Okay, so dehydration reaction is example of beta elimination reaction. In beta elimination reaction, which alcohols are more reactive? Reactivity of the alcohols towards the elimination reaction. Reactivity of alcohols towards elimination reaction. Towards elimination reaction. So which alcohol is more reactive towards the elimination reaction?
Tertiary alcohol.
Very good, Samhita. So which alcohol is more reactive towards the elimination reaction means here. So tertiary alcohols are more reactive. Okay, so which alcohols are more reactive means here? Tertiary alcohols are more reactive than secondary. Secondary alcohols are more reactive than primary alcohol. Now we got the clarity. Ritu. So yesterday absent Ritu. Right. So one more example, here. Here, if I had here, three different alcohols are there. So which alcohol is more reactive towards the elimination reaction? That is my question. Three different alcohols are there, ma? In the three different alcohols, which one is more reactive towards the elimination reaction?
I think the third one.
Third one or first one?
Why so?
Because of greater the conjugation, ma. Greater the conjugation means electron density is decreases on the carbon atom, na? That means here cleavage, removal of the OH group is now you are telling that tertiary alcohol is more reactive. Is that clear, Samhita? Okay, this is the tertiary alcohol, and this one is sorry. So here CH, we can take as a CH. This one is the secondary alcohol. Now, why you are telling that tertiary alcohol is more reactive towards the elimination reaction? Because of alkyl groups are electron donating groups. Number of electron donating groups are increases on the carbon atom. Electron density is going to be increases. Okay. On oxygen atom also already electron density is there. Greater the electron density means greater the repulsion forces. Greater the repulsive forces means easily bond breaks here. Okay. The bond is going to be breaks easily. Okay. The bond is going to be breaks easily. Similarly, here also what happen if the conjugation is going to be increases means donating capacity is going to be increases now. Number of donating groups are there. Number of donating groups are increases means bond easily going to be cleaves here. But in this one, any electron donating groups are there? Is any electron donating group it is there in this one? No, na. So according to that one, which one is means here? So this one here. So reactivity order. Okay, second one, first one is more reactive than second one. Second one is more reactive than that of the first one. Okay, so if you see all these cases, in all these cases you are having the secondary alcohols only. In all the cases you are having here secondary alcohol only. In that also, which one is more reactive means here first one is more reactive. So because of greater the conjugation means electron density is going to be increases. Okay, electron density is going to be increases. So that time what happened? Bond easily going to be cleaved. If the bond is going to be cleaved means what happened here? Stability of the here formation of the product also we can explain the stability of the carbocation. Okay, formation of the product also we can explain the stability of the carbocation. Reactivity also we are going to be explained based on the stability of the carbocation. Okay, now better we'll take as a reactivity can be explained the stability of the carbocation. So now you got the clarity, Samhita. Reactivity, we are going to explain the stability of the carbocation. That is point here.
So
Now,
then there's two double bonds, there's more electron density on OH. So it's more prone to reactivity.
yes, ma'am. Number of double bonds are increases means reactivity is going to be increases. And at the same time, if it undergoes to the unsymmetrical cleavage, if it undergoes to the unsymmetrical cleavage means it forms as a carbocation. It forms as a carbocation. Now here also we are getting as a carbocation. Here also will get as a carbocation. And here also will get as a secondary carbocation. Here also will get as a secondary carbocation. If you see in this one, which one is more stable? Which one is more stable?
First one.
First one. Why the first one is the more stable, Samhita?
Because the double bonds are not present.
It undergoes to the resonance. If you see resonance concept means number of resonance structures are increases, that stability also is going to be increases. Is that clear? Now this one it forms as a two resonance structure. This one it forms as a only one resonance structure. Actually total number of resonance structure for this one is will get as a 3. So this one will get as a 2 resonance structure. For this one there is no resonance structure. Number of resonance structures are increases, their stability also is going to be increases. So due to that reason only third one is more reactive towards the elimination reaction. Now we got the clarity. Okay, and same concept. So if we take for the unsymmetrical alkene, okay, so that's why to explain the unsymmetrical alkenes only, okay, so that's why I explained the reactivity. Now unsymmetrical alkenes, sorry, unsymmetrical here, for example, CH3 bond, CH bond, OH bond, CH3 bond. Okay, so this one, this we can call as a 2-propanol. 2-propanol. If the 2-propanol is heated with concentrated phosphoric acid, H3PO4. It is heated with the concentrated phosphoric acid. If it is heated with the concentrated phosphoric acid means what is the product it is going to be formed? Can you guess? What is the product is going to be formed? What is the product it is going to be formed? Ritu, Aditi. Is Aditi only logged in? Yes. So all these are the examples of the dehydration reactions. But what is the product it is forming? What is the product it is going to be formed?
So the first one, propene is formed.
Ma?
Propene is formed for the first one.
Very good, ma. So first one it forms as a propane. That means CH3 bond, CH double bond, CH2. Okay, so propene plus water molecule. And what about the third one?
So I don't know if the double bond forms in the benzene ring or here.
So first I'm going to write as like this. Otherwise I'll give the numbering 1, 2, 3. Now the double bond is formed in between the first and second carbon atom or second and third carbon atom. That is my question. Is the double bond is formed in between the first and second or second and third carbon atoms?
First and second.
Very good. So why it is the first and second only? Why not the second and third?
Markovnikov's rule.
Okay, it is a Markovnikov rules. It is a Markovnikov rule. Markovnikov rule means more stable. The alkene which is attaches with the more number of alkyl groups, it becomes as a more stable. Hence, the double bond is formed in between the first and second carbon atom. Okay, so this one CH bond, CH3 is the product. Okay, according to the Markovnikov rule. And generally we can call as Sagejev rule. It is not the Markovnikov rule. Addition reaction we can follow as the Markovnikov rule. Okay, so this we can call as a Sagejev rule. Sagejev rule. Okay, and this also we can call as a JEE, SEV, JEITSEV, JEE rule also we can. According to the Sagejev rule, JEE rule means here the alkene which is attaches with more number of alkyl group, it becomes as a more stable. Okay, so what is it means here? The alkene which is attaches with the more number of alkyl groups, it becomes as a more stable. Now we got the clarity. Okay, so this is the one condition of the dehydration reaction. So what is the another condition means here? Here, if the temperature is going to be decreases at low temperature, so generally we are taking as a high temperature only, na? Okay, so we are taken as a 170 degrees centigrade. So at 170 degrees, in presence of concentrated sulfuric acid, means it forms as an alkene. At the same time, you had taken concentrated phosphoric acid also, it undergoes the dehydration reaction, it forms as a alkene. In presence of alumina at 300 degrees also, it undergoes the dehydration reaction, it forms as a alkene. Here, if it is condition small, condition is changed here. So what is the condition means here? Here, alcohol CH3 bond CH bond. I'm taking ethanol. I'm taking ethanol. CH2 bond OH. So 2 moles of the ethyl alcohol is treated with concentrated sulfuric acid at 140 degrees centigrade. Concentrated sulfuric acid at 140 degrees centigrade. If it is 140 degrees centigrade means it is also it undergoes to the dehydration reaction. But in this form, it forms as a ether. What is the product it forms means? It forms as a C2H5, O bond C2H5 is going to be formed. It forms as a diethyl ether. It forms as here diethyl ether is going to be formed.
So why is like that if we increase temperature?
Ma?
Why does it form an ether?
So why does it forms as a ether means it is a condition actually. Okay, at low temperature reactivity is less na. If the temperature is going to be increases means reactivity also is going to be increases. Okay, so at low temperature first it forms as a ethers. Again, if you increase the temperature means it becomes as unstable. Then it undergoes the elimination reaction. Okay, again if you increase the temperature means again it undergoes to the elimination reaction and it forms as a CH2 double bond CH2 byproduct, it forms as a C2H5OH because of ethers are unstable. Ethers are highly unstable. There we can call as a volatile, highly volatile. What is maybe the volatile, Samhita?
Highly reactive.
It's not the highly reactive, ma. Volatile is not. The volatile is
Or
not
highly,
highly
it can
reactive.
evaporate very quickly.
Ma?
It can evaporate very quickly.
Actually, so volatile means the liquids which are easily interconvertible from one form to another form. The liquids are easily converted into so one form to another form. That means ethers are liquid actually. Okay, ethers are liquids. They converted into the gaseous form. They converted into gaseous form at room temperature only without applying any heat. They converted into the gaseous form. Like camphor, like naphthalene, like petrol. Petrol also it is highly volatile. Whether it is highly volatile or not. Petrol is highly volatile or not. Is petrol is highly volatile or not, ma? Samita. Have you seen camphor at least? Samita, Ritu, Aditi.
Yeah, sure.
Okay. So camphor is highly volatile. That is what we call a sublimable also, sublimation also.
Yeah, sure.
Okay. Right. So that's why here what happened, whenever you heat at high temperature means it undergoes to the elimination reaction and it forms as a alkene. Okay. So now you got the clarity. Now we got the clarity, ma. So this is the reaction condition we are having here. Okay. So based on temperature, once you check it out here, whenever you're writing the products, you had to check it out the temperature also. You have to check it out the temperature also. 16 me, Ritu, some issue, audio. Right. Now next reaction here. So this is the one reaction and the remaining reactions also we already seen. Okay. So remaining some reactions we already seen. So what are the reactions we already seen means here where we had seen some reaction means in the preparation of haloalkanes. In the preparation of haloalkanes we had seen some reactions. What are the some reactions means? For example, if the alcohols, if it is treated with hydrogen halide, that means hydrogen iodide. If it is hydrogen iodide means what is the product it is going to be formed? What is the product it is?
RI?
Ri. Very good, Samhita. It is going to form as a Ri plus H2O. Okay. Again, if the alcohol sir reacts with PCl3, so what are the products it is going to be formed? We already seen all these reactions in the preparation of the haloalkanes.
Yes, sir. R RCl,
R,
Cl,
Cl,
I think HCl is also formed.
HCl.
No.
It's not the HCl, ma. In this one, 3 moles of the alkyl chloride and H3PO3 is the product.
Yeah. I got confused with the H. I person.
H3PO3 is the product. Okay. And if the alcohols are treated with PCl5, R bond OH, R bond OH it is treated with the PCl5. If it is treated with the PCl5 means what is the product it is going to be formed? Any guess?
Okay, so RCl.
RCl, S Samhita is correct only.
And something it reacts with P also. PCl3, I think. No.
PCl3 or POCl3?
POCl3.
POCl3
And
plus
then one more H. Yeah, HCl.
HCl is the product here. Okay. And if R bond OH is reacts with thionyl chloride, that means SOCl2. SOCl2 is the product.
RCl plus HCl plus HO2.
RCl plus HCl plus SO2. So can you tell me the name of the reaction? We had given some name for this reaction. We had given some name for the reaction. What is the name of the reaction? What is the name of the reaction? What is the name of the reaction, ma? Dargent's reaction. Dargent's reaction is one of the best method to synthesize the alkyl halides. Dargent's reaction is one of the best method to synthesize the alkyl halides. Okay, so why sir the alkyl Dargent's reaction is one of the best method means because of HCl is the gas and sulfur dioxide also gas. Both are expelled into the atmospheric air. Then finally it gives us a pure alkyl halide. Okay, so finally it gives us a pure alkyl halide. Now you got the clarity. All these are we studied only last time. Preparation of the haloalkanes. And one more also it is there. So what is another test means here? Grooves process, something we can call. So alkyl hydrogen iodide in presence of ZnCl2. Okay. And another one is we can call as a Lucas test. Did you remember? Lucas test. So Lucas test is used to confirm whether the given alcohol is primary or secondary or tertiary. So first of all, what is mean by the Lucas reagent? Last time I told that. Lucas reagent. Aditi, what is mean by the Lucas reagent? What is mean by the Lucas reagent? Samhita?
Sir, is it zinc chloride with HCl, concentrated HCl?
Very good. Zinc chloride with the concentration HCl. Anhydrous, zinc chloride, plus concentrated HCl with concentrated HCl. Okay, anhydrous zinc chloride and concentration HCl is called as a Lucas reagent. Okay, now here tertiary alcohol is there and secondary alcohol and primary alcohol. So tertiary alcohol is treated with the Lucas reagent. Tertiary alcohol is treated with Lucas reagent. If it is treated with the Lucas reagent means it forms as a tertiary alkyl halide. So which one it is going to be formed as here? It forms as a tertiary alkyl halide. Okay. So tertiary alkyl halide is formed immediately. So first for the tertiary alcohol, if you add 2 to 3 drops of the Lucas reagent means it forms as a tertiary alkyl halide. It forms as an immediate turbidity. Immediate turbidity. And secondary alcohol. So for the formation of the turbidity or formation of the PPT, it takes 5 minutes of the time. It takes us here 5 minutes of the time. If the turbidity is formed within 5 minutes means that indicates the presence, that confirms the presence of the secondary alcohol. But primary alcohol at room temperature, it does not form as a precipitate. It does not form PPT. Okay. At high temperature, okay, it forms precipitate. Okay, so now we got the clarity. This is the one confirmation test of the alcohols. All these reactions we already studied at preparation of the haloalkanes. Okay, so all these reactions are we studied at here, preparation of haloalkanes. I think so all of you forgot this one. Forgot all this one. Forgot or remember?
No, sir.
What about Samhita? What about you?
No, sir. And
Then you're not giving answers. Somewhat you tried. Of course, that is good only.
sir, I forgot, sir, until you explained.
So once you revise, let us say organic chemistry, na. So whenever you're listening, you may, and it look like as I understood, you understood. But after few days, after 2 or 3 days, without knowing any idea about that panna, again it look like as a new concept, you are listening. Again, it look like as you are listening as a new concept. But all these reactions we studied there only. Where we studied preparation of the haloalkanes. Okay. Now we got the clarity. Right, ma. So then, shall we go for the another reaction? Oxidation reaction. So from here onwards, slightly it is a new concept to us here. Oxidation reaction. Oxidation reaction. So what is meant with the oxidation reaction? What is meant with the oxidation reaction? What is the definition for the oxidation reaction? Can you please give me the definition? Then only I'll go for the further step.
Adding oxygen,
Addition
removal
of
of hydrogen.
addition of oxygen. Addition of oxygen. Addition of oxygen. Then second one is removal of hydrogen. Removal of hydrogen. So these two concepts, all of you, do you remember now? Addition of oxygen is called as a oxidation reaction, and removal of hydrogen also we can call as a oxidation reaction. Okay, so based on that one, let us see more. So here, what we are taking means here addition of oxygen. Sir, actually we have a two types of the oxidizing agents. We have two types of the oxidizing agents are there. First, I'll give the list of the oxidizing agents. So we have a partial oxidizing agents. Partial oxidizing agents. Okay. And strong oxidizing agents. Another one is we have a strong oxidizing agents. Strong oxidizing agents. Okay, so one is having here partial oxidizing agents, another one is we are having strong oxidizing agents. So what are the examples of the partial oxidizing agents? Means we can take as a PCC. So PCC is nothing but pyridinium chlorochromate. So let that here pyridinium chlorochromate. Pyridinium chlorochromate. And PDC. So PDC is nothing but pyridinium dichromate. Pyridinium dichromate. So one is the pyridinium chlorochromate, another one is pyridinium dichromate. Okay, and what is another one means here? We have a Jones reagents. Jones reagent. Sir, what is meant by the Jones reagent means? Jones reagent is nothing but chromium trioxide CrO3 in presence of H2SO4, or we can take as acetone. We can take as acetone. So acetone chromium trioxide in presence of H2SO4 or acetone is called as a Jones reagent. Okay, and Collins reagent. Collins reagent. Pyridinium dichromate. Pyridinium dichromate also. Okay, so Collins reagent. Collins reagent. Collins reagent. So what is meant the Collins reagent means? Collins reagent is nothing but here it is CrO3 and dipyridine to C5 dipyridine. So C5H5N. C5H5N mixture. So this mixture only we can call as a Collins reagent. Okay. So all these are that as a partial oxidizing agent. And what are the examples of the complete oxidizing agents? I think so you may studied about this one.
KMNO4, K2CrO7.
Very good, ma. So KMNO4. Which KMNO4? Acidified KMNO4. Acidified KMNO4. And what is another one means here? K2Cr2O7. Acidified K2Cr2O7 also act as a strong oxidizing agent. To make you confused, sometimes in place of potassium dichromate, they're giving us a sodium dichromate, Na2Cr2O7 in presence of H plus. Okay, sometime they're giving us a Na2Cr2O7 H plus. Okay, now in this one, so first of all, we'll see what is mean by the partial oxidizing agent. The partial oxidizing agents is nothing but they'll add only one oxygen. How many oxygens they're adding? They're adding only one oxygen. For example, okay. So for example, here we have a primary alcohol, secondary alcohol, tertiary alcohol. Now here addition of oxygen or removal of the hydrogen also we can call it as a oxidation reaction. First of all, I'm taking as a CH3 bond CH2OH. CH2OH. So we are adding as a only one oxygen. Okay, we are adding as a only one oxygen. Now once you check it out here. Okay, so
Sir, is an aldehyde formed? Aldehyde formed?
It is converted into the aldehyde. Okay, that means we are removing these two hydrogens. If you remove these two hydrogens and write the product as easily CH3 bond CHO plus byproduct is H2O. Okay, so removal of the hydrogen also we can call as a oxidation reaction only. Okay, removal of hydrogen also we can call as a oxidation. Now, first of all, whatever the alcohol we had taken, either it is a primary alcohol, it is our secondary alcohol or tertiary alcohol. Primary alcohol or secondary alcohol? There it is primary alcohol. Katta disko, gatti katta disko, sorry, mala raadu. Primary alcohol. So primary alcohol is it undergoes to the oxidation reaction means it forms as a aldehyde. Primary alcohol it undergoes to the oxidation reaction means it forms as a aldehyde. For example, if you had taken secondary alcohol, CH3 bond, CH bond, OH bond CH3 it is that. Okay, so this one is called as the given alcohol is primary or secondary or tertiary. The given alcohol.
Secondary.
Secondary. If the secondary alcohol means here also we are removing the hydrogens only, ma. If you remove the hydrogen means the double bond is formed between the carbon and oxygen atom. If the double bond is formed between the carbon and oxygen means it converted into CH3 bond, C double bond both CH3. Now it is converted into aldehyde or ketone.
Ketone, sir.
It is converted into ketone. Okay, now secondary alcohols are converted into ketones. Okay, secondary alcohols are converted into ketones. Primary alcohols are converted into aldehydes. So now you got the clarity. Okay, then what about the tertiary alcohol? Is tertiary alcohols are it undergoes the oxidation reaction? No? Is tertiary alcohols are it undergoes the oxidation reaction with the partial oxidizing agents? Is any possibility is that to form? Is
I don't think so, sir. No.
No. So because of there is no hydrogen at tertiary carbon atom. There is no hydrogen at tertiary carbon atom. So that's why tertiary alcohol it does not undergoes to the positive or partial oxidation reaction. Okay. Now we got the clarity. So according to that one, what we can say, primary alcohols are converted into the aldehydes, secondary alcohols are converted into the ketones, tertiary alcohols are they does not give the positive test here. Okay, and if you take in place of that one, here if you take the strong oxidizing agents, here only I'll give the clarity. Strong oxidizing agents. What are the strong oxidizing agents are there? CH3 bond, CH2 bond, OH. If it is treated with strong oxidizing agent, that means KMnO4 in presence of H plus or K2Cr2O7 in presence of H plus. K2Cr2O7 in presence of H plus. They act as a strong oxidizing agents. If they act as a strong oxidizing agents means they convert the primary alcoholic group into carboxylic acid group. That means CH3 bond COOH. So this one is converted into the carboxylic acid. Okay. And here one condition is there. CH3 bond CH bond OH, bond CH3. Okay, so in this one also, if it is treated with the strong oxidizing agents, if it is treated with the strong oxidizing agent means here in this one, let us see, one is converted into the carboxylic acid CH3 bond, COOH, another one is CO2 plus H2O is going to be formed. So the OH attached to carbon is converted into the carboxylic acid group. Sir, you had taken secondary alcohol, okay. Why we can't take another molecule means CH3 bond, CH bond, OH bond, CH2, CH3. How it is going to be converted, ma? How it is going to be converted? It is also secondary halo. This is also is called as a secondary halo. So this carbon is converted into the carboxylic acid. C3, COOH. And what about the CH3, CH2? This carbon. So this carbon is converted into the carboxylic acid. That means it is also formed as a CH3 bond COOH. Now we got the clarity. If terminal carbon atom it is there means it is converted into the carboxylic acid. If the terminal carbon atom is there means it is converted into the carboxylic acid. Now we got the clarity. Still anyone you having doubt? Now we are having doubt, ma? Any one of you? And what about the tertiary alcohol? Tertiary alcohol.
Does reaction not happen again?
No, ma. Whenever you as a tertiary strong oxidizing agents mean they undergoes to the dehydration elimination reaction and they form as a alkenes. CH3 bond, CH3 double bond, CH2. This is the product it is going to be formed. Okay. So no reaction. 1 second. 1 second. I only get the confused. Okay. Clear? So we'll continue tomorrow, Maya. So until here you understood now? All of you? Aditi, Samhita.
Yes,
Yes,
sir.
sir.
Okay, so then remaining part will continue tomorrow. Okay. Thank you all.
Thank you, sir.